will start with the basic concept of hexagonal cell formation. So, just a quick recap of this basic concept. So, here you can see that these blue cells are actually the portions of some wireless communication cells. Those are using the same group of frequency. So all ones are using same group of frequency. But as they are kept apart by some distance strategically, so their interference is less. That is the main philosophy of making cellular communication. So this is the meaning of cell. Similarly, the cell number 2, all cell number 2s are using another group of frequency, but these are same group of frequency within this 2. So 1 and 2 are actually using different sets of frequency, but all 1s are using same frequency and all 2s are using same frequency. Similarly, all 3s are using same frequency and all 4s are using same frequency. So this is the philosophy of cellular structure or the frequency reuse philosophy. Now, in this case, one question arises that when I am getting this k is equal to 4 or k means the cluster size, then how I am getting this value 4 actually? So basically, k, okay, k is equal to I square plus ij okay. So basically, this k is equal to 4 is actually coming from So suppose this 4, I am starting from this 4, this cell. So suppose my goal is to reach from one cell to another co-channel cell. So I have already told you the meaning of co-channel cell. It means the cells that are using same set of frequencies. So for example, suppose from this cell, I want to reach another co-channel cell. So this 1 to 1, I want to reach. So how should I reach? Suppose this is the center of the cell. So from center of the cell, I will start my journey in such a way that this path maintains a 90-degree angle with one of its edges. So this is one of the edges of the hexagon. So I am simply moving forward. And I am reaching to the center of the other cell. So this is my distance. Now, during this process, how many straight lines I am making? See, I am making only one straight line. And this straight line is the same straight line where I started from. Okay. So, when I am starting from one cell, so the variable that is called I. So, that is the starting straight line. And J means if I have made any bending after reaching some point. So in this case, I have not made any bending. So straight away from one cell to another cell, I have traveled very easily. Now my question is, how many cells I have traveled in this line. So see, if I have started from this center of the cell, so how many cells I am passing through? So first, here I am passing half of the cell. So 1 by 2. Okay. Here I am passing the full cell, full one cell. So this is 1. And here again half cell. So 1 by 2. So what is the total number of cell that I am passing from one to another? That is half plus 1 plus half. That is 2. And these two I have achieved by traveling only through a straight line, that is called I is equal to 2. And J means if I have made any bending while traveling from one cell to another cell. Have I made any bending? No, I have not turned any angle. So that is why J is equal to 0. So now this expression of K is actually K is equal to I square plus Ij plus J square. Okay. So I square. So the value of I is 2. So 2 square plus J value is 0. So 0 plus 0. So that is why this is 4. So in this way I am getting the cluster size 4. Clear? Now I am applying the same technique on this. So in this case, for this example, see, suppose this is my desired, suppose this is my cell number 1. Now from one cell, I am liking to or I wish to reach to another cell. Okay. Now how to do that? So suppose I am starting from the center and I am just crossing the boundary perpendicularly. Okay. And then I have reached out at this cell. And then I made a turn of, suppose if I am continuing like that, see, I will not get any co-channel cell. So at this point, I need to bend by 60 degree. So I am making a turn of 60 degree and then I am reaching towards this cell. So this angle is actually 60 degree angle. Similarly, suppose I want to reach to this cell. So again, I will be traveling from here like that. And after reaching at the center, because if I move like that, so I will not get the nearest co-channel cell. So that is why I will again turn 60 degree and then again I will reach to this cell like that. So now, how to understand the concept of frequency reuse in that manner, that I am explaining. So again for this, if you take this example, I am going in this way, and after that I am bending like that 60 degree, 60 degree angle like that. So in this case, how to calculate the cluster size? Okay. So first we need to understand that how many cells we are traveling in my first run without bending. Okay. So I'm erasing for clarity. Then again I will draw it. So let us start with this cell. For example, I will reach from this cell to this cell. So first I will pass through this edge like that, and then I will stop here, and then I will make a 60 degree turn like that. So now in this way, we need to identify how many cells I am traveling in this two straight line. So this straight line is actually I and this straight line is J. Now I need to count the cells. So I am starting my journey from this point. So this point to this edge, that is 1 by 2 or half cells I am covering. From this point to this point, full one cell I am covering. From this point to this point, again half cell I am covering. Okay. And from this point to this point, this is half cell and this is half cell. So along I am covering total half plus 1 plus half. That is 2. Okay. And along J, I am covering half plus half. That is 1. Now we know that formula, that K is equal to I square plus Ij plus J square. That formula we know. So I square means 2 square. So 2 square plus Ij, it means 2 into 1 plus J square, it means 1. So 4 plus 2 plus 1 is equal to 7. So in this way, we can calculate the cluster number of cells in a cluster or cluster size. Okay. So suppose if I ask you, I am not telling directly the cluster size. Instead of that, I mention I and J strategically. So then you need to calculate K by using this formula I square plus Ij plus J square. Now suppose take this example. Okay, so this is a further larger cluster size. So see, in this case, what is happening? So suppose this is the cell number A. So from this A, I want to reach another A. So I am starting my journey straight like that. Then after reaching there, I am bending and I am reaching at this cell. So this is called I, you know that, and this is called J. So if you look at the cells, number of cells that we have traveled, so here we have traveled half cell, here we have traveled 2 cells, and here we have traveled further half cells, and here along J we have traveled half cells here and half cells there. So what will be the value of I? So value of I is half plus 2 plus half. So that is why the value of I is 3. Okay. Next, value of J. J is equal to half plus half is equal to 1. No, sorry. This is half plus 1. So that is 2. 2. Okay. Because half plus half plus half. Half plus 1 plus half. Like that. So this is 2. So along I straight line, it is covering 3 cells. And along J straight line, it is covering 2 cells. So the value of K is equal to I square plus Ij plus J square is equal to 9 plus 9 into 2, 18 plus 4. Okay. Have I done this correct? Okay, sorry. Here I have made the mistake. So 9 plus 6 plus 4. Sorry. 9 plus 6 plus 4. So that is 15 plus 4. That is 19. Right. So in this way, we are getting the cell size or cluster size. So in the question, if I ask you that directly, I am not mentioning the cluster size. Rather, I will mention in such a way that first I am moving uh, straight up and covering 3 cells. Then I am turning 60 degree and then I am covering 2 cells. Then what is the co-channel interference? Like that, suppose if I ask you. So first you need to calculate K. That is the first task. First you need to calculate K. Once you calculate K, then by using this formula Q is equal to D by R is equal to root over 3K, you can compute co-channel interference. So what is the significance of this Q? So what is the meaning of this Q? So Q means co-channel interference reduction factor. So Q means co-channel interference reduction factor. You should remember this terminology. So what is the Q value for different cluster size? So for example, suppose K is equal to 4. Okay. So for K is equal to 4, the formula is Q is equal to root over 3K. That is the formula. So it means if K is equal to 4, so then Q is equal to root over 3 into 4 is equal to 3.46. When K is equal to 7, it means Q is equal to root over 3 into 7, that is equals to 4.58. Again, Q is equal to root over 3 into 19, it means 7.55. So what is the significance of this? The significance of this, Q means what? Co-channel interference reduction factor. It means if the value of Q increases, it means interference decreases. Interference decreases. That concept you need to have. So if the value of Q increases, then the interference decreases. So when my cluster size is 4, okay, then the Q value is 3.46. But when my cluster size is 19, then the Q value is 7.55. So what is happening here? So you know that if the value of Q is small due to K is equal to smaller value, then co-channel cells are very closer. So see, if K is equal to 4, then these co-channel cells, for example, these 4 and 4, these are co-channel cells. So these are very closer. However, suppose if K is equal to 7, then the co-channel cells are a bit farther compared to K is equal to 4. And if this K is equal to 19, for this case, these co-channel cells are much farther compared to the previous ones. So why the interference is reducing? Because the co-channel cells are going farther. Okay. Another significance that we can get from the significance of K. What is the significance of K? So the significance of K is if the K value is higher, so definitely Q value will again go higher. Okay. So in other terms, we can say that for large K, low interference. Okay. And for small K, high interference. Okay. So small K means what? K is equal to 4. This is a small value. So definitely this is having high interference. And for large K, it means, for example, K is equal to 19. So the co-channel cells are placed apart. So that is why it is having less interference. So this is all about the co-channel interference reduction factor. So now we will start the concept of carrier to interference ratio. So what is carrier to interference ratio? So carrier means the desired signal that a mobile phone wants to receive. Okay. So carrier signal power means when a mobile station is communicating with the base station, then what is the desired carrier signal power it should have? Okay. Okay. But when a user, suppose it is sitting on here, suppose the mobile station is sitting here. So the base station is also sitting here in the same cell, hexagonal cell. So this base station is communicating with this mobile station. Everything should happen within that cell only. Now, if you look at this figure, suppose this third figure, if you look at, or the second figure, if you look at, better to look at this third figure. So, see, if this A is a cell, okay, now immediate nearest cells are 6 in number. So, if I connect or make one circle enclosing this nearest co-channel cells, so we will get total 6 nearest co-channel cells. Now, if I repeat the pattern more and more to cover a very large area, so definitely there should be a second layer of this circle where the next nearest cells will be there. So that is why whenever I am looking for any cell, so these 6 cells will be called the first tier cell. The 6 cells should be called as the first tier cells. And when any interference, probable interference is likely to happen, it might happen only due to these cells more significantly. Because when this mobile station is communicating with this base station, being in this cell, at that time, the same frequency can affect as a interference from these cells. Okay, so this is the cells that are using the same set of frequency as used by the central cell. There are other cells also, those are using again the same frequency, but these cells are very far. As these cells are very far, so this is very less chance that some interference is possible to this cell. This is very less chance. So whenever we are interested to analyze carrier to interference ratio, we are more interested to analyze the interference that one cell can have from the 6 immediately neighboring cells. Okay. So if I have a simplified formula for this carrier to interference ratio, and you must remember this. So this carrier to interference ratio is actually C by I is equal to Q to the power N by 6. This 6, why 6? Because 6 means the 6 number of cells that is corresponding to this first tier. So that is why the value 6 is coming. Okay. Now, what is Q here? Q means root over 3k. Okay. So, C by I approximately equal to root over 3k to the power n and divided by 6. Now, what is n? N is called the path loss exponent. What is path loss exponent? Path loss exponent means whenever some signal will come from these co-channel cells to these cells, so there will be some path loss. Okay, this path loss have a factor. Okay, I mean by which rate the path loss will occur. It has a number or a power. Okay, an exponent. So that is n. So now let us take an example. Okay, example is, for example, k is 7. What is k? K means the cluster size. So cluster size is 7. What is n? N is called the path loss exponent. So these two values are given and your task is to calculate C by I or carrier to interference ratio. In this case, the first duty is to calculate Q. We know that Q is equal to root over 3K. Now, as in this problem, it is given K is equal to 7. So, the value of Q should be root over 3 into 7 or root 21, that is 4.58. Now we need to calculate C by I, that is equals to Q to the power n divided by 6. Now in the question it is given the value of n is 4. Okay, so 4.58 to the power 4 divided by 6 is equal to 73.4 that we are getting. Now, whenever some carrier to interference or signal to noise, all this ratio comes, or we are comparing the signal powers, okay, in the form of ratio, it is a engineering technique or engineering standard to convert this into decibel. Now, how to convert this into decibel? So, signal to interference ratio in decibel is equal to simply 10 log 73.4 dB 10 base 10. So 10 log 73.4 base 10 and the unit should be dB, should be in dB. Okay, and if you calculate this, this should be 18.66 dB. This is 18.66 dB. So these type of problems are the important aspects, okay, from this calculation where the cluster size is given and your path loss exponent is given, and you need to calculate C by I. Clear? So this is all about this unit 1. So for your convenience, I'm just repeating that. So repeating means what? How to get the cluster size. So cluster size can be obtained from the shift parameter. So shift parameter means what? I'm again repeating that. For example, I want to reach from this A to this A. So first I should follow the straight line I, then I should follow the straight line J. This is the technique of frequency reuse. So along I, how many cells I am traveling? So see, from the center to this is 0.5 or half cell. Then I am covering 2 cells. Then I am covering 0.5 or half cells. So the value of I should be 0.5 plus 2 plus 0.5. So this is 3. Now after this point, I am bending by 60 degree because this line is going straight like that. I won't get any co-channel cells here. So this 60 degree I am getting, and then from again this point to this center. So how many cells I need to travel? So here the half cells 0.5, then the 1 cell, and then again 0.5. So J is 0.5 plus 1 plus 0.5, that is equal to 2. So the value of I is 3 and J is 2. So the value of K is I square plus IJ plus J square is equal to your 9 plus 6 plus 4. So the value is 19. In this way, even if the cluster size are not given directly, you are supposed to calculate the cluster size in this manner. So when you get the cluster size, so for example, for this also, how to get the co-channel cell. So I am starting from this any cell you take. Suppose this is 1. So simply I am going this side, this side, this side. I am stopping here, then reaching this side. So this is my path. So this the dotted line is my I and the solid line is the J. So along the dotted line, how many cells it has covered? So half, 1, half. So the value of I should be half plus 1 plus half, that is 2. And after that, it has turned 60 degree and covered half plus half. So J is equal to 0.5 plus 0.5 is equal to 1. Now if I calculate k, that is I square plus ij plus j square, that is 4 plus 2 plus 1 is equal to 7. Okay. And the easiest example, that is this one. So from one cell to another cell, it does not need any bending. So that is why it is going straight away. So only I line is getting followed. So how many cells it has traveling? First it is traveling half, then 1, then half. So half plus 1 plus half. So that is why I is equal to 2. And it has not, it does not contain any bending. So that is why there is no j line. So the value of j is 0. So I square plus ij plus j square, it is becoming 2 square plus 0 plus 0 is equal to 4. Okay. So we now got the idea of the shift parameters. We have the idea about the cluster size. We have the idea about the co-channel interference reduction factor. We have the idea about the significance of Q. We have the idea of the significance of K. And also we have the idea of carrier to interference ratio. And if the cluster size is given and path loss exponent is given, then how to calculate C by I, that relationship also you know.